Hello there and welcome to this video on multiplying and dividing rational expressions. We will be working through some examples of both of these topics during this video. They are very comparable to how you would simplify a rational expression that is only one fraction. We are essentially just going to simplify each of the two numerators or more than two numerators all as much as possible by factoring them, and then do the same for all of the expressions in our denominators, factor them as much as possible, and then we'll be dividing out common factors on the numerator and denominator to simplify as much as possible. So let's get started with problem number one. We have some numerator with a quadratic here of x squared minus 4, and then we have 6x squared and 3x as our cross each other here, and then x plus 2. So the first thing I would do is factor x squared minus 4. That's difference of squares, which you guys practiced yesterday. So that would factor into x plus 2 and x minus 2 for the numerator. And then my 3x, nothing I can do with that one, so that is just going to be 3x. And then x squared and 6, I could split that 6 into 3 times 2 and split the x into x times x. And I'll do that here, 3 times 2 times x times x. But most of you guys will not need to have to set it up like that. It's just an option for you. You could just leave it as 6x squared if you wish. And then x plus 2, we want to keep in parentheses, but it's as factored as possible. Now that we have everything simplified as much as possible, we can look for dividing out common terms on basically either numerator or either denominator. So the first thing I would do is, well, I know that x plus 2 is in common with this x plus 2, and we can divide both of those out. I also have a 3 and a 3 that I could divide out. And then I can divide out, lastly, one of our x's on the top and the bottom. What I have left over is on the top left, I have x minus 2 in parentheses left over. And then I have a 2 and an x left over in this numerator. In my first denominator, I just have nothing or just a 1 left over. In my second denominator, I also have just 1. That means that x minus 2 times 2x would be as simplified as I can make it. I could multiply this out, but generally speaking, your answers in these types of problems will be factored completely and not multiplied out again. Remembering, factoring and multiplying are opposites, the same sort of way that multiplying and dividing are opposites, since factoring and dividing have a lot of similarities. But we have finished this problem, and I could also write it as the reverse since it's all multiplication. Both of these circled options would be the correct answer. Now let's move to problem number 2. So with both of these, you'll notice that they are division problems. So before we get started with any of those, just a quick review on how we divide fractions. So let's say that we were doing 3/4 being divided by 2/3. So in order to divide by a fraction, you might remember from an earlier grade that that means we have to flip over the second fraction, and let's do that again. You have to flip over the second fraction and then multiply by the reciprocal of that same second fraction, or the upside down version of it, which means that our answer would be 9/8 for finding basically 3/4 divided by 2/3. And a similar idea would be like if you are dividing by something by 2, that's the same thing as multiplying by a half. 1/2 and 2 are also reciprocals. Moving to our problems themselves, they're going to work exactly like multiplication problems, except we need to flip our fraction over first. So for problem 2 here, that I've kind of marked in green there. So the first thing I would do is rewrite our first fraction identical to what we have already, and then keep parentheses around anything with subtraction involved. And then I'm going to flip the second fraction upside down. And so we have now a multiplication problem to do now that our second fraction has been flipped. So now we want to factor each numerator and denominator as much as possible. So 4x squared and 20x, if we look at the numbers they have in common, the biggest number that 4 and 20 have in common would be 4. And then they also at least have one x in common. So that means that 4x is its greatest common factor together, and that will leave behind x and minus 5. And you can always multiply that out again to see if you've done it correctly. And then 3x in our denominator here is nothing, is going to stay the same. We don't need to change anything about it. And then our second numerator, well, 6x and 30, the most they have in common is a 6. That's their greatest common factor. And so x plus 5 would be left over, and you can multiply that out again to check it. And then x squared minus 25 is another difference of squares. So we would just do the square root of x is x. The square root of 25 is 5. And then you just make 1 plus and 1 minus. And that would be factored completely there. Our last step is trying to divide out any common factors that are on the top and bottom of either of these two fractions, since we just have multiplication happening. So we have 1x plus 5 and an x plus 5 we can divide out. And then I can divide out an x minus 5, like so. And I also can divide out an x. So those are gone. And lastly, I have a 3 and a 6 on the top. So I can divide by 3, giving me a 2 up there. And so now if we look at what we have left over, well, we have on the top 4 and then a 1. And then we have a 2 left over and then a 1. So this whole thing ends up actually being equal to 8, which is quite unexpected for this type of kind of lengthy problem. And we're going to move on to another division problem after this to practice a little bit more of that. So now we have, and let's remember that I wanted to give you guys a second to copy that down. So pause the video there if you need to copy that one down. Now moving to the third problem of our video. So we have to first, like before, keep our first fraction the same, x squared plus 4x over x squared minus 9. And then we have x plus 3 on the top now, and x cubed minus 16x. Like so. Now we can try to factor all of our parts. So our first numerator, we can take out an x, factor out an x, and we're left with x plus 4. Our first denominator is another difference of squares. So I would find the square root of x squared. And then the square root of 9 is x and 3. And then we have a plus and a minus version of the same thing. Our second numerator is done already. And then this last one, we have some interesting stuff going on because it's x cubed now. So the first thing we have to do is take out a common term. So that would be taking out x. And we're left with x squared minus 16. But that we're not done factoring that one because x squared minus 16 is a difference of squares. So that would become x plus 4 and x minus 4. And we have x plus 3. And The rest did not change. And was recopying our factored versions of all of our problems here. So we have everything done now. So now we can start dividing out factors that are on the top and bottom. Like we have an x plus 3 and an x plus 3 we can divide out. We have an x and an x we can divide out. And then an x plus 4 and an x plus 4 we can divide out as well. So you'll notice that on the top we have nothing left. So that would just be a 1 on the top. And then we have x minus 3 and an x minus 4 on the bottom. And note that when you have multiplication, we can really write things in any order we like. So I could write these parentheses in the opposite order with x minus 3 first if I so chose. So make sure to pause the video there and copy down the work for this problem as well. Moving to our second to last problem, we have a kind of larger problem where we have lots of factoring to do, which we'll kind of remember that when you have factoring and you have a 1 in front of x squared, you're really just looking to see what two numbers add up to the b and multiply to the c. And we have multiplication here, so we don't need to do any flipping of any fractions. So to start off with our first numerator, since we have 1x squared, we're just looking for numbers that add up to -1 and multiply to -12. Well, those two numbers are going to be -4 and +3. So we have our factor version of that, first numerator. Our denominator we've seen already before. We already know that's x plus 3 and x minus 3. So that one's a repeat from earlier. Our second numerator, we have a 1x squared, so we just got to add up to -2 and multiply to -3. And that means we have -3 and +1. And finally, we're looking to add up to -2 and multiply to -8. And that means that we have x minus 4 and x plus 2. All that's left for us to do now is look for common factors on the top and bottom. So I can divide out x minus 3 first. I can divide out x minus 4 second. And I can divide out x plus 3 as well. So you can see that all those have been kind of crossed out on the top and the bottom. And the only thing I'm left with at the end of this problem would be x plus 1 and x plus 2 on the bottom. A note before we do our last problem, I recommend putting all these in parentheses before you start, so you know that like the subtraction and or addition is kind of gluing those all together. And if you were to put this whole original problem into Desmos graphing, it would come up with a graph. Now, if you put in this new graph here, well, then you would know that you have the same thing on the graph if you did it correctly. And that's something to keep in mind when you're checking your answers in other problems. Now for our final problem, we have another division problem. And so we are going to flip that second fraction upside down first, and then go through our steps again. Our first fraction is unchanged. And now we're flipping our second one so that x plus 5 is at the top, and x squared plus 4x plus 3 is on the bottom. So let's try to factor all of our parts now. So the two numerators we can see are done already. So we can just write those both really quickly. Now, x squared minus 25 we've seen before. That's another difference of squares. Square root of x squared and square root of 25 gives us a factored form of x plus 5 and x minus 5. And this one, we're just adding up to 4 and multiplying to 3. So the two factors would be positive 3 and positive 1. And we now can just look for common terms. So we have an x plus 3 on the bottom and the top. we have an x plus 5 on the top and the bottom. And that means we're kind of left with just the 1 on the top. And we're left with x minus 5 and x plus 1 on the bottom. And that completes our last multiplying and dividing rational expressions problem example. Hopefully you've noticed that this should feel pretty similar to what you watched or saw for simplifying rational expressions yesterday. And that will conclude our lesson for today. Thank you for watching.